Hmm. Today our topic of discussion is to derive Schrodinger time independent wave equation. Actually, initially we consider a particle is moving with certain velocity. Okay. In quantum mechanics, we know that we study the microscopic particle. If we want to study the microscopic particle, so it is not possible directly to measure the different parameters regarding the particle. So according to de Broglie hypothesis, we know that if the particle is moving with certain velocity, then a wave is associated with that particle. And obviously, from that particular wave, we can identify the particles and we can study the particle. Is it? So by knowing the value of wave function which is associated with that particular wave, we can derive Schrodinger time independent equation. Okay. So initially I consider uh, particle is moving with a certain velocity v, and as particle is moving with certain velocity, obviously it is associated with a wave which have a certain wave function, and we know wave function we represented it by psi. Okay, so I consider three-dimensional. I consider a system of stationary wave to be associated with the particle. Then three-dimensional differential wave equation is del 2 psi by del x square plus del 2 psi by del y square plus del 2 psi by del z square equal to 1 upon u square del 2 psi by del t square. In this case, psi is nothing but the wave function, u is nothing but wave velocity. I write this equation as del square psi equal to 1 upon u square del 2 psi by del t square. So in this case, this del square represent the Laplacian operator and it have the value del 2 by del x square plus del 2 by del y square plus del 2 by del z square. And u is nothing but the wave velocity. So this differential equation have the solution as psi equal to psi naught e to the power minus I omega t. In this case, psi naught is the constant value and it represents the amplitude of that particular wave. So psi naught becomes amplitude of particular wave and psi becomes the wave function of that particular wave which is associated with the particle. So if I differentiate this value with respect to t twice, because I have to calculate the value of del 2 psi by del t square. So for this, I differentiate this value of psi twice with respect to t. Then what we get? Del 2 psi by del t square equal to. This is the constant value. So this constant value of psi naught is as it is. E to the power of minus I omega t as it is, because if we differentiate the value of e to the power of minus x with respect to x, then we know that we get it is e to the power minus x as it is and derivative of minus x is minus 1. In similar way, I differentiate this e to the power minus I omega t with respect to t. So I write it as psi naught become constant e to the power minus I omega t. For single differentiation, I get minus of I omega. Again differentiating, again we get minus of I omega. So minus minus we get plus value I into I square, omega into omega, omega square. So I write this equation as I square omega square psi naught e to the power minus I omega t as it is. So from this equation 2, I write this psi naught e to the power minus I omega t as psi. So del 2 psi by del t square as it is equal to minus of I square becomes minus 1. So I write it as minus of omega square psi. So if we put this value of del 2 psi by del t square in equation 1, we get So from this equation, I write del square psi equal to, if we put this value of equation 3 in this equation, we get del square psi equal to minus of omega square psi upon u square. So we know that omega, that is omega equal to what, 2 pi nu, and nu be the frequency, and in terms of wavelength we know that velocity equal to frequency into wavelength. So frequency equal to velocity upon a wavelength. So if we put this value, we get omega equal to 2 pi u by lambda. So omega square upon u square we get, it is 4 pi square upon lambda square. So omega square upon u square, this value, when we put in equation, in this equation, then we get del square psi equal to minus of 4 pi square upon lambda square into psi. In this equation, lambda is nothing but the wavelength of de Broglie wave, and according to de Broglie hypothesis, we know that wavelength have the value, that is h upon p, where h is the Planck constant and p with the momentum. So if you put that value of lambda in this equation, obviously we get del square psi plus 4 pi square upon lambda 4 pi square upon lambda square psi. If you put the value of lambda, then we get del square psi plus 4 pi square p square upon h square into psi equal to 0. So we know that value of h cross is h upon 2 pi. Value of h cross is h upon 2 pi. So from this, 1 upon h cross is 2 pi upon h. So 1 upon h cross square is 4 pi square upon h square. If we put this value of 4 pi square upon h square as 1 upon h cross square, then we get the equation del square psi plus p square upon h cross square into psi equal to 0. So I represent this equation as equation number 4. I want to calculate the value of momentum p. So I consider a particle is moving and having total energy capital E. So I consider, let E be the total energy of a particle. Then we know that total energy becomes, it is the summation of kinetic energy and potential energy. So I write it as E equal to kinetic energy plus potential energy, and kinetic energy we can write in terms of moment, in terms of velocity also, that is half mv square also, and that half mv square we rearrange it in terms of momentum, and we know that for kinetic energy of a particle, then having certain mass m, then we can write it as p square upon twice m. So from this equation, if we calculate the value of p square, then we get it is E minus V multiplied with twice m. So P square equal to twice m into E minus V. So if we put this value of momentum P square in equation 4, we get del square psi plus twice m upon h cross square into E minus V psi equal to 0. I denote this equation as equation number 5, and this is nothing but the Schrodinger type independent wave equation, where t variable is not there. So in this case there is no variable, time variable, so it is independent, time independent wave equation. And if the particle is free particle, if the particle is free particle, and we know obviously that free particle having potential energy 0. So for a free particle, what will be the Schrodinger time independent equation for a free particle? Just put the value of potential energy becomes 0 in this case. So we get del square psi plus twice m upon h cross square E psi equal to 0. This is for a free particle. and we can write this equation as del 2 by del x square, del 2 psi by del x square plus del 2 psi by del y square plus del 2 psi by del z square plus twice m e upon h cross square psi equal to 0. So this is nothing but the derivation of Schrodinger time independent wave equation, and it is we can derive it also for free particle by putting the value of potential energy. Thank you.